to be focusing on the isometric circle. I thought I'd put this together for you in terms of the fact that it looks almost like an ellipse. So the construction method is obviously which sets it apart from the ellipse. And I'm going to go ahead and draw the isometric square in which the isometric circle fits. However, to explain this concept, one's got to realize that you can fit a circle into a square. I'm going to go ahead and draw the circle on this end over here. Okay, let's quickly complete that circle, and then just show that if I had to have two horizontal lines at a tangent, that I'd obviously have a square that will surround. Okay, in this case, almost like an inscribed circle. But you can see that on either side, the circle is touching, and therefore we know that this is going to obviously be a square. And to test that theory, my diagonals should be at 45 degrees to one another, so that would be obviously 45 that way and 45 that way, and that will obviously be the center of the square and obviously the center of the circle, proving that this is a square, and obviously the circle then touches each side of the square. Okay, so in this case here we have a 2D shape, and we've got to realize that we have the circle inside of a square. Therefore, if we want to go and draw a 3D circle or a 3D square, I've got to make sure that I have that at 30 degrees, and I'm going to give it a size. I'm going to simply go and give it 40 millimeters. I'm going to construct it on this way over here as well, and I'm going to just make sure that everything is 100% accurate. Okay, so I've got 1, 2, 3, 4. Make sure that you are accurate and that you are drawing your lines at 30 degrees. I'm not going to make it 41 millimeters, but I'm trying to make it 40 millimeters. So each one of these sides must be accurately drawn. And if you need to, and I'm drawing it in dark because I want to show you the construction method for the purpose of this video. So I'm going to go ahead and measure each one of these and make sure that they're all exactly 40. Okay, so this one here could give me a slight bit of problems. Okay, maybe my angle is out by half a degree, but it is pretty much 40 millimeters. Okay, so I'm going to go ahead and I'm going to construct my isometric circle by simply placing the obtuse angle to opposite side. So I'm going to go ahead and divide this one into two pieces at 20, obtuse angle to opposite side. I'm going to take the center of the opposite angles, and this point over here, I'm just going to quickly drop these measurements. I'm going to just double check whether they do measure up to 20 millimeters. So that one's 20 millimeters and that one's 20 millimeters. Okay, so I'm wanting to split each line into two equal parts, bisecting those lines. I've just done it via measurement, and what I'm going to do is I'm going to go from obtuse angle to opposite side, so that I have an upright V. So I'm drawing this in dark just for the purpose of this video, but you have to draw it in construction line, please. Okay, so I'm showing you how to go about constructing an isometric circle. So here's your upright V. Make sure that you are making sure that you're going from an obtuse angle, an angle that is bigger than 90 degrees, not from the smaller angles. Okay, and then I'm going to do it the other way around as well. So from this obtuse angle to this opposite side as well, the center of the opposite side. Here we go. Okay, and what it gives me is this point over here and this point over here. Now you need to recognize that you have a diamond shape yet again. As per the ellipse, you are recognizing this diamond shape, and you need to make use of these four corners of the diamond. to draw the necessary arcs from. Okay, so I'm going to go ahead and line up my arc, or the center points. Making use of the center points. Now it's important for the purpose of this video to have a look at which point gets placed where. I have the metal point that is going into the center point there. Remember, I'm using the 4 corners of my diamond to scribe the arc, so I'm accurately placing it in there. And then I'm going to open up my compass to there. I make a touch on the side here. Before I draw the circle, I make a touch on the side over here. Once you're happy that they do meet up, I go scribe the arc. Now in this case over here, you must please realize that you are also going to be taking that same size arc to the other side. So I haven't changed the size of my compass, okay, and I'm going to make sure that I'm meeting the necessary requirements here. Here I'm definitely not accurate. It touches over here, but it doesn't on the other end. So I'm going to just cut it a little bit short. You can see there that it's not quite meeting up, okay, but you can also see that what I'm doing is I'm taking this square over here, I'm placing my square over here like that, and then I'm going to start placing my arcs of the circle where need be. And there are obviously 4 of them, so there's one here, there's one there. So I've now covered both these ones. Now I need to get this one over here and this one over here on that side there and on this side here. I've used this corner and that corner for both these arcs, so now I'm going to use this obtuse corner over here like that, and I'm going to open up all the way, because one end of the arc needs to join the other end of the arc. So there it is there. I'm just going to test whether it touches this side and whether it touches this side. Indeed it does, but I definitely am not accurate. So this is maybe a good example of how you can go wrong, and before you even scribe your arc, you can test whether it touches here and here, and whether you're accurately going to be able to reach one another. Now this is caused by some inaccuracy in either degree or length of line. Okay, so you need to be 100% accurate when drawing it, and you can see how easily you can go wrong. Right, I'm going to go to the opposite angle now. I'm taking that over there. I've used that corner. I'm now going to use this corner. I keep the same size. I touch this side, I touch that side, and yet again I have something that's not quite accurate. Okay, now obviously if you're going to have one portion inaccurate, it's going to cause an inaccuracy somewhere else. And this is very good for this video, because now you can see that once you have in fact gone ahead and touched over here and touched this side here, don't draw this arc over here, because you can see that they are not meeting up. Rather go ahead and go and fix up your construction line, get it more accurate, and then go ahead and do the test again whether they can touch on this end, touch on that side, and when they do, you go ahead and draw the complete arc. At this point in time, I'm going to leave the mistake on this video, just so that you guys can see what mistakes there can be made and what you could be running into if you are inaccurate. And the other part is that you've now seen the entire 2D shape. Now you've got the 3-dimensional version of it as well. So recognize that this circle over here fits inside of its square. I had to draw the square first before I could construct the isometric circle inside of it. I have to recognize that it touches on all 4 of the sides, and so it does exactly the same on all 4 of the sides over here. Right, I hope you enjoyed the video, and please give us a like on YouTube. Thanks. Hi there guys, so today we're going to be joining 2 isometric circles to form a cylinder. You'll recognize this drawing from our previous video. So you'll also notice that I've left it inaccurate, that my points didn't join up. And this is something that you need to obviously get right. That is also displayed in the construction of the isometric circle. However, for the purpose of this video, we're simply going to go ahead and use this isometric circle to go and join a cylinder. Right, so what we are concerned about is the fact that we need to be able to carry all these measurements up Okay, and we need to be able to go and construct another isometric square. There are shortcuts in using this method, and I will discuss it after the wrong method is done. Okay, I'm using this corner over here so we can separate the two isometric squares that I'm going to be constructing. I'm using a 30-degree set square. Alright, and I'm also going to be projecting what I have, or the information I have, from the bottom over here all the way up, because that'll give me the center points, the opposite centers of my opposite to obtuse construction process. There they are there. Okay, so it's much easier now. Okay, remember that what we did was we bisected or simply just found the measurement. If this was 40, that would be 20. You have to be quite accurate, so to the millimeter you'd need to make sure that you're accurate in this instance. And then we're going to go from obtuse angle to opposite center, and obtuse angle to opposite center with an upright V, and then the upside down V that way as well. And you'll notice that we are going to be intersecting at these points over here. But what's quite pertinent here is that you see that there's a line drawn through the middle over here, and that line also goes through those 2 points. Just recognize that you have to use these 4 corners of my diamond to be able to construct my isometric circle. However, now that I'm going to be putting or making it a cylinder, I'm now not going to see a portion of this arc over here in the back, because that now becomes hidden detail. But for the purpose of the video, you could make everything in construction. I've just kept it nice and dark to explain my construction of the isometric circle. Now I'm going to have another isometric circle at the above. I'm going to go ahead and I'm going to construct what I need. And what is important is to realize that I test the theory here, I test over here and see whether it touches this side here. I'm definitely inaccurate, and I'm going to place the nip a little bit so that I can get it to work for the purpose of this video. The top portion is going to be seen. I'm going to take it to the other side. I'm going to do the same. I'm going to try and get it to touch this side and touch that side. Okay, I get it to do so. It tells you where to start and where to stop. Okay, and then I'm going to open up my compass all the way so that one arc end can meet the other. There, so, and I test the theory. I test it on this side, I test it on this side. They do meet up, so I go ahead and I go and draw it. And then I do the opposite angle as well. Touch it over there, and I get it to touch on this side over here, and I get them to join. Now I have 2 isometric circles, and what I want to do now is I want to join the 2 isometric circles to one another to form a cylinder, and that's all it really is. So I go ahead and I make sure that I have another one of those lines going from the smallest corners, or the acute angles, okay, and you'll see that they also go through those corners over there. So there it goes, a line going through there. At the top I've got another line going through there, and where they meet over there on the arc, that will be where I'll simply join my line from one isometric circle to the next and try and get it to blend in with that arc as well. Alright, so you've got on the other side, you've got the exact same thing, and your brain is already starting to form this picture for you, which is brilliant, because the more you draw, the more you're feeding your brain with the image. And there we go. Alright, and there's my cylinder. Just recognize that there's a portion of this that needed to be in hidden detail, okay, because I will be able to see the front portion, the front curve, and then obviously the entire top base. I'd like to explain the center line situation over here. And we are working on an isometric circle, so I'm going to go with 30-degree angles. I'm going to go through my center, but remember you have to line up your two centers over there and make sure that you pass your center line so that it passes through and sticks out the other end of the circle. I'm going to do the same at the top, so that my two isometric circles, which are separate entities, are also used. There we go. The top portion and the bottom portion has its center lines nice and separate. Okay, let's make sure that it breaks the line there too. And now to prove that it is an isometric cylinder or an isometric shape, I have to put the axis through the middle. Remember, we don't want to change the shape, we simply want to add to it, enhance it rather, and make sure that our shapes have all the necessary information to fully explain what it is. So in this case over here, the isometric circle has its own center lines, the one at the bottom has its own center lines, and then obviously there's one going right through the middle to show that this object, which is a cylinder now joined with these two lines, has a center and can swivel and rotate on that center. Well, thanks for watching, guys. You guys have now seen how we've taken it from a 2D shape through to a 3D shape. Make sure that you can go back on the video, you can pause and redraw and practice your drawings. Good luck.